In our previous video, we looked at the three identities. So now we want to look at the difference of two squares and its applications. After learning that when I multiply the difference and the sum, I get difference of two squares, then in order to factorize the difference of two squares, it is very important for us to write the expression so that the squares are clearly seen. For instance, if we have a squared minus 9b squared, we want to factorize this. So we are going to convert each term we have into its square, meaning that the 9 must be converted to its square. That gives us a squared minus 3 squared b squared, whereby we bring 3 and b in a common bracket and we give them a common square, thus giving us a squared minus 3b squared. But this is a difference of two squares, which we have already seen that it is got after expanding and simplifying the sum and difference. Therefore, that means that this was got after expanding a minus 3b and a plus 3b. The same applies to part B, where we have 1 minus 16x squared. We shall change the 16 to its square, which is 4 squared. And of course 1 is a square number because 1 times 1 is 1. So it gives us 1 squared minus 4x squared, which is the same as 1 plus 4x into 1 minus 4x. That is how we shall factorize difference of two squares. The same applies to part C, where we have 4x squared minus 25y squared. We shall express the 4 and 25 in their squares. We know that 4 is 2 squared, 25 is 5 squared. Therefore, we shall have 2 squared x squared minus 5 squared y squared. Then we bring the 2 and x in a common bracket and give them a common square, so that we have 2x squared minus 5y squared. After having two clear squares, then we take their sum and the difference. That is 2x plus 5y multiplying 2x minus 5y. That is how we factorize difference of two squares. However, some expressions which involve the difference of squares requires us to always find a common factor first. For instance, if we look at our example 9.12, where we are told to factorize 7x squared minus 7y squared, you realize that the 7 is not a square number, but it is a common factor. whereby we shall first take the 7 outside, hence giving us 7 into x squared minus y squared, and then that becomes a difference of 2 squares, which is expanded by multiplying its sum times its difference. Therefore that gives us 7 into x plus y into x minus y as our answer. The same applies to part B, where we have 3x squared minus 75y squared. If you look at 3 and 75, there is a common factor, which is 3, because 75 by 3, you get 25. So we shall take the 3 outside and remain with x squared minus 25y squared, where the 25 is changed into a 5 squared. Then we combine 5 and y and give them a common square. So that becomes 3 into x squared minus 5y squared. That gives us difference of 2 squares, where we can expand them to find 3 into x plus 5y into x minus 5y as our final answer. The difference of 2 squares can also be used in evaluation of some expressions that involve numbers in a faster way. For instance, if we are given 99 squared minus 1, if you look at such a problem, could be hard for you if you don't use a calculator, or if you don't have this knowledge of difference of 2 squares. If someone finds you on the way and asks you, what is 99 squared minus 1? But we can solve this using the idea of difference of 2 squares, because 99 squared is already square, and 1 is also square, because 1 is 1 squared. So we can have 99 squared minus 1 squared to give us 99 plus 1 and 99 minus 1, whereby we shall have 100 times 98 to give us 9,800. The same applies to part B, where we have 8.49 squared minus 1.51 squared. Still, we can have 2 brackets, one for the sum and one for the difference, whereby we shall have 8.49 minus 1.51 into 8.49 plus 1.51. So we could work out problems faster using difference of 2 squares. So here are some of the numbers that you can try out during your free time, and remember, practice makes improvement. Goodbye.